Welcome to part 2 of solving equations. Today we're going to work on some more difficult equations where we have fractions in the problems. So I want us to take a look here at example E. Alright, example E. And notice we have a fraction in the problem. Now, I will tell you, anytime you're solving an equation, if you've tried to compare your answer to anybody else's, you might have found that you did different steps than they did. Alright? And that is okay, because there are multiple ways to get from the beginning to the end of a problem. All you have to do is make sure that each of your steps is done correctly. You may have more steps or less steps. You may have different steps, but just as long as you do each step correctly, you will come to the same answer. Now, you see that we have a fraction here, and that's a pain in the butt for us because we really hate to deal with fractions. What we're going to be doing today is learning how to get rid of fractions so that we don't have them and that the problems we do have are easy to solve. So first thing I'm going to do, would you agree, I've got a -1 here, and there's a lovely 12 sitting over there, and it would be just really easy to add 1 to both sides to get that thing over there. And I have already made my problem a little bit easier. Okay, so then I have 2/3 x equals x plus 13. Now, the next thing, you might think subtract x on both sides, and that leaves me in a position where I have 2/3 x minus x, which is a pain because now I'm adding and subtracting fractions. We know we hate that, right? So what I'm going to show you how to do instead is get rid of fractions. So what we're going to do is we are going to get rid of fractions. And the method for doing that is multiply by the denominator on both sides. So let's write this. Get rid of fractions. And we want to multiply by the denominator on, don't forget, both sides. Okay? There's our strategy. So, what's your question?
Can you also multiply by the reciprocal?
No, it'll make a mess. Because then you're going to have, if you multiply by the reciprocal, would you agree this is going to be 3/2 x? And you still have a fraction and it's a problem. Yeah, so it's...
Wait, so I would do times 3 by both sides?
We are going to multiply both sides by 3, so times 3 here. Put this side, because you have two things over here added, right? Put them in parentheses and multiply by 3. The next thing you need to do is simplify both sides. So would you agree, when we multiply by 3, which is really 3/1, those 3's cancel and we only have 2x left. Now on this side, we need to distribute. Distribute our 3, and that's going to give us 3x plus 39. Now we have a problem that is easy to solve. We know how to do these. We are good at these. We didn't have much questions on these last night. Subtract 3x on both sides. When I do that, I have negative x equals 39. Divide both sides by -1, and I have x equals negative 39. All right? So let's go ahead and do example F. All right, we're going to do the same thing. We can't, though, add 1 because the 1 is stuck in a denominator or in a numerator, right? So you can't add 1 to both sides. Can't do that. It's trapped there. You have to release it by getting rid of the 5 in the denominator. So multiply both sides by 5. Go 5/1 here by 5 over here. This 5 and this 5 are going to cancel out. Then you're going to have 3x minus 1 equals 35. Now you have a problem that's easy to solve. So add 1 to both sides. And you have 3x equals 36. Divide both sides by 3. And you have x equals 12. Fair enough? Seeing the pattern here?
So, I have a question.
What's your question?
You can just multiply the number you want to put on the other side. You don't have to add the other number. Like how you did in the first one, you did 2, it was 2 or 3, you just multiply by 3, you don't have to add the 2.
You're only multiplying by the denominator. All right, go to the next example. And this is a little more challenging because We have two denominators, right? So now what do? You're going to multiply it by whatever the lowest common denominator would be. So you have a 5 and a 3. So would you agree the lowest common denominator is 15, right? That's the smallest number 3 and 5 divide into. So I'm going to write LCD, that's lowest common denominator, equals 15. And what I'm going to do is everything gets multiplied by 15. So over here on this side, times 15. Here, put this in parentheses, times 15. Put it over 1 if that helps you. If it helps you, put it over 1. Now, notice something here. You probably want to cancel the 15 and the 5 right now, right? Don't do it. You have to distribute the 15 to this fraction and this fraction. Because if you cancel here, you're only going to distribute a 3 over here, and that's not going to work. You need to distribute the 15 to both. So here's what I'm going to do. 15 times 6, that's going to give me 90, over 1 times 5, which is 5x, minus 15 times x is 15x. 1 times 3 is 3. And then over here, going to need the calculator here. 39 times 15 gives us negative 585. Now, it still looks like I have fractions, right? However, do the division. They will both divide out. So this, 90 divided by 5 is 18. So you're going to have 18x. 15 divided by 3 is 5x. Equals negative 585. Combine like terms, this gives you 13x equals negative 585. Divide both sides by 13. And let's get the calculator out. We have x equals 45, negative. All right? The last one. This is probably the most complicated one. These are the ones when you get to the homework are going to give you trouble. This has so many bombs in it waiting for you. First of all, you don't have single digits in the numerator. You have, these are called binomials because they have two terms. And you have a minus right here. Let me show you how to work through one of these problems. Might I recommend work it through the long way until you get the hang of it. When you get really good at this, like I can do this in a couple of steps because I know what I'm doing. Let yourself get used to the process so you don't mess it up first. Then you can start making shortcuts. Would you agree? I've got a 4 and a 3 and a 2. What do you think I'm going to multiply by? 12. So here's what I'm going to do. Over here, LCD is going to equal 12. So over here, I've got a fraction, so I'm going to multiply by 12 over 1. Over here, I have two things. I'm going to put these guys in brackets, and I'm going to put 12 over 1 in front of them. All right? Follow how I do this. I want you to distribute to this fraction and this fraction, but not to the y and the 2 and the y and the 3. Don't do that. Watch how I do this. So I'm going to take the 12 over to here and over to here. So this becomes 12 times y plus 2 over 1 times 4 is 4. Do you see how I got that? I'm just distributing the 12. We're not actually distributing it to the y and the 2, just in front of the y plus 2. Just in front of it. Then do this one. 12 y minus 3 over 1 times 3 is 3. And over here, 1/2 times 12, that gives us 6. So do you see what I've done so far? Still have fractions, just put the 12 in front of the binomials. Now I'm going to cancel, okay? So 4 goes into 12 3 times. 3 goes into 12 4 times. I'm going to need a new color for this. Now we'll distribute, now that we've canceled. So we're going to distribute the 3 to the y and the 2. And over here, we are actually distributing negative 4 to the y and the negative 3. So here's what I have. 3y plus 6 minus 4y, and negative 4 times negative 3 is plus 12, and that equals 6. On your left-hand side, you have some like terms. Combine them. I've got a 3y and a negative 4y. This gives me negative 1y. 6 and 12 give me plus 18 equals 6. Subtract 18 from both sides. And I'm going to just move this up here because I'm out of room. I've got negative y. Make sure to bring that negative. Whoops, let's get more of the paper on the screen. Equals negative 12. Divide both sides by negative 1, and you have y equals 12. All right, so those are some fraction problems. Bear with me while we do one more formula problem. So turn to page 11 of your notes, and you'll see example C we haven't done yet. And in example C, we have a formula which has an A, a T, an X, a B, a C, and a D. And what we want is X by itself. First thing to do, it looks like distribution, right? Distribute. So we're going to distribute here, 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 and here. So this is going to be 3 ATX minus 2AB equals CDX minus 2C. Now, we need all the things because we want to get X by itself, right? So let's move all the X's to one side. So what I'm going to do is I'm going to move this way. And the way I'm going to do that is subtract CDX on both sides. So 3ATX minus CDX minus 2AB equals negative 2C. And what I need to do now, I just want the X's over here. So what I'm going to do is move this guy over here. So we're going to add 2AB. So I've got 3ATX minus CDX equals negative 2C plus 2AB. Now the next thing I'm going to do, I'm going to go to the side and we're going to do an example that has nothing to do with this problem for me to show you something. Would you agree? 3x plus 2x is 5x, right?
Yes.
In our minds, what we're really doing is 3 plus 2x, which then equals 5x, right? So we're just adding the 3 and the 2. And that's how we got the 5 for the 5x. So this is what we're doing in our minds. We're adding the 3 and the 2. We're going to do the same thing. We are going to add this with this. And so what we end up having is in parentheses 3AT minus CD x's. But here's the difference. Over here, we can combine a 3 and a 2, right? Over here, we can't combine this crap. It doesn't combine, so it's just got to stay that way. And this equals negative 2C plus 2AB. However, by doing this, we now made it easy to get X by itself. Just divide by 3AT minus CD on both sides. So here's what we have. X equals negative 2C plus 2AB over 3AT minus CD. And there is nothing you can do with that. That's as simple as it's going to get.